For the last video this week, I wanted to give you just some extra practice over all of the things we just talked about. So here are 4 questions, and some of them deal with means and some with proportions, some with probabilities, some with the empirical rule. So I really would like for you to press pause and try all 4 of those questions. So please take your time, look back at the examples that we just did, and then go through these step by step, because the more practice you do this week, the better off you're going to be in the 3 weeks to come. So press pause, try all 4 questions, and then press play, and I'll take you through each step by step. Hopefully you've taken the time to do the 4 questions on the other screen. I did mix it up and give you a little bit of everything in here, so hopefully you've had a chance to go through and try each on your own. So again, here I'm looking at the fact that I've got a probability or a percentage, which is a proportion. So I know that this is not a sampling with means question, it's a sampling with proportions question. And 300 would be N, that's the number of candies. And the probability that no more than 20% of them buy M&Ms, this tells me that it's not an empirical rule question, but I'm finding the probability. So the first thing, of course, I have to do is to do the conditions. And the conditions are randomization. It's not stated, so sometimes it's not going to state that, but we're going to assume buyers were chosen randomly. 10%, we will assume 300 candy buyers as less than 10% of candy buyers. Independence, whether or not a customer buys M&Ms is independent of other customers, particularly because they're chosen randomly. And success fail, N times P, N times Q, both are greater than 10. And again, because the conditions are met, we can use a normal model, and then I have found the new standard deviation of the sample. So biggest mistake people make is to not find that standard deviation. Drawing our picture, remember we're expecting the 40%, but we're looking at the probability that no more than 20%. So that's 20% or less, and notice this is the side that's shaded. So this, just looking at the picture, I know that probability should be less than 50%. The calculations would of course be the z-score, and the z-score is found using this mean and this standard deviation, so be very careful. So again, I'm going to do observed, or my guess, which is 0.2, minus expected, which is 0.4, so this is always the real mean, over 0.0283, and then of course that will give me a z-score, and then that will also, once I use my calculator or use StatCrunch to find the probability. And then notice the way that I'm writing the solution. The probability that P is less than 0.2 equals the probability that Z is less than my Z-score that I found. And essentially when I plugged it in, I got a very, very, very small number. Whenever you get those numbers that look like, say, 3.42, and that's not my answer here, I'm just making this up, and then E negative 15, that tells us that I'm going to take this decimal and go 15 places this direction. So it's basically 14 zeros and then 342. So this number was very, very small, and so we said essentially the probability is 0. So according to the normal model, the probability that in a sample of 300 candy buyers, no more than 20% of candy buyers buys M&Ms is essentially 0. And my next question, it's pretty clear pretty quickly that I'm dealing with means rather than proportions. So the mean weight of US men is 190 pounds with a standard deviation of 59 pounds. It's kind of a big standard deviation. An elevator has a weight limit of 10 persons or 2,500 pounds. Find the probability that 10 men in the elevator will overload the weight limit. So again, I'm dealing with means. I have to check the conditions. So randomization, that was kind of tough. We don't know that they're randomly selected. What I can do here is a little bit of a cheat, because yes, I can talk about randomization, I can talk about the weight being independent, but I know that weight is a randomly distributed variable, just like height is a randomly distributed variable. And so I know I can use the normal model. And the normal model is 190, which is the mean, and then the standard deviation is not 59, it's 59 divided by the square root of 10. Now my picture, of course, should have the 190 in the middle because that's the mean, and my question is the weight limit of 10 persons or 2,500 pounds, which is essentially me saying that each person would weigh an average of 250. So notice that's the number that I'm using here, so this one was a little bit tricky. So I'm using the number 250 because I'm saying if each of them weighed 250, then we would overload 250 or more, which is why I shaded to the right, then we would overload the elevator. So for our calculations, of course, I'm going to say observed or predicted 250 minus 190 over the standard deviation, that's what number I got when I divided those things together. And I got 3.2159. So I know that's going to be a very, very small percent because it's past 3 standard deviations, but I'm going to find the probability. So the probability that y bar, or that my mean, is greater than 250 equals the probability that z is greater than 3.2159, which is my probability, which is essentially 0.065%. So when I'm writing my conclusion, according to the normal model, there is less than a 0.07% chance that a sample of 10 men in the elevator will overload the weight limit. Okay, for our next question, 74% of college freshmen make it to their sophomore year at Brigham U. We take a sample of 400 freshmen. Using the empirical rule, describe what we might see amongst these freshmen. So again, am I dealing with a proportion or a mean? Well, it's 74%, so that tells me that this is a proportion question. I'm not finding the average number, I'm looking at a percent of a whole. N, of course, is 400, and now I'm going to check my conditions. Conditions are random, 10% independent success fail. Again, note that I checked each using words and not just yes. Calculations, now this one I'm going to do the calculations to find the mean and standard deviation, but my picture won't come until later because I'm looking at the empirical rule. So my mean is of course 0.74. My standard deviation is PQ over N, the square root of PQ over N, which is about 0.0219. Again, make sure you don't round this off too much or you'll be incorrect. And then don't forget, because the conditions are met, I can use the normal model and tell me what that model is. My picture, of course, will be just what the empirical rule looks like. So I started with 0.74 in the middle, I subtracted the standard deviation going to the left and added going to the right. And then my conclusion is essentially telling you what I see on the picture. And last one, I'm dealing with 200 randomly chosen 18-year-old women that have a mean weight of 140 pounds. For all 18-year-old women, we expect the mean to be 143.74 and the standard deviation to be 51.54. Again, this one's specific, using the empirical rule. So I know I'm using the empirical rule, and I know I'm doing it for means because this is not obviously a proportion question. So describe what we might see, and then we'll come back to this other question once we make our empirical rule picture. So again, the conditions, again, random, 200 18-year-old women were randomly chosen. 10% for a large college, 200 is less than 10% of the population. Independence, women's weights are independent of one another. Large enough, N is greater than 30 because again, N was that 200 randomly chosen. The conditions are met, so our calculations are the mean, which is given to us. The standard deviation, remember we always divide it by the square root of N, and that gives me 3.644. And then because the conditions are met, we'll use the normal model, and notice I'm giving you the model. The picture is, again, using the empirical rule. Now, in this question, it says, describe what we might see and comment on whether 140 pounds seems unusually low. So looking at this picture, 140 pounds is really close to right here. Well, that's just one standard deviation away. So I wouldn't comment, I wouldn't think that that's unusually low because it's within one standard deviation of what we would normally expect. I wanted to add just one more question, because we want to take a look at when we're choosing a sample size and we don't really know perhaps what the margin of error is or what the critical value is, etc. What they do give us is the current sample size and then what they want us to do with the margin of error. So we don't know what the margin of error is, but in this case we know that we want the error to be only 1/5 as large. So essentially what that's saying is that I need this number to be 5 times greater. So it's really easy to say, oh, well, if it needs to be 5 times greater, I'm going to take 100 times 5 and that would give me a sample size of 500. And that is incorrect, because notice that n is inside the radical, which means we're taking the square root of n. So what I want to have happen is I need the answer inside to be 5 squared times as large, or in this case that would be 25. So let's look at it using the actual numbers, and then when we try this one down here, I'm not going to use the actual numbers. So here I know that the square root of 100 is 10, and I need 10 to be 5 times larger because it's the denominator, which means I'm dividing, which means that's going to make this value smaller. So I need the square root of what equals 10 times 5, or 50. And then of course the answer to that would be found by squaring each side. So x would be 2500. Now that's all well and good, but what if I give you something like the square root of 300, which doesn't come out to be a nice whole number? Then I have to deal with decimals. So really the easiest way to think about it is to say, well, I know that whatever number they give me here is going to be square rooted. So in this case, I'm saying 1/3 as large. So right now n is 300, and I want it to be 1/3 as large. Remember, that means I need the square root of 300 times whatever. I need this to be 3 squared, because 3 squared, that means that the squared would cancel, and therefore this would be 3 times greater. The solution would be 3 times greater, which means the margin of error would be 1/3 as large. So what does that tell me? That means I need it to be 300 times 9, because 3 squared is 9. Just like here, we did it times 5 squared. So 300 times 9 is 2700, and that is the sample size that I would use.